Hey everybody, thanks for tuning in. I thought I'd make a quick little video just about integration by parts with a couple examples. We can go from there. So integration by parts is an integration technique that integrates products when some of the other techniques don't work. So a couple techniques we've talked about is U sub. And this is a integral of a product. But if you choose U and du, you can integrate that. Another one would be, x times e to the x squared. Again, if you choose u as x squared, you've got a strategy. What I mean by manipulation is if you have, some product like this, you could, FOIL it out, expand it out, and then, take the integral of each term separately. So integration by parts is going to be when those techniques don't work. So let me give you the formula real quick. It looks kind of funky to the newbies watching. It's kind of like U substitution, but instead of just using one function, we're going to have two functions. We're going to have a U and a V function, essentially. So I'm going to kind of just use an example and jump right into it to explain the notation, and then we'll do a few more after that. So an example of when we could use this is let's say we are asked to integrate, x e to the x. It's a product, and I can't simplify it, and U substitution doesn't work. So what you're going to have to decide to do is we're essentially going to define one of these functions as U, because the formula has some u's in it. And then the other function, this is where it gets kind of weird, the other function I'm going to essentially classify as dv. And dv here is kind of the other part of the left side of this. And I suggest when you set these up that you try to stay organized, but I'm going to set u equal to one of the things and dv equal to the other part. And if you look at kind of the goal here, just applying this formula directly, it says that the integral of u times dv is equal to u, which I already have, u is x, times v. And we can find v because v is going to be the antiderivative of dv. And so whether you want to think of it with the little integral symbol, or you want to just say, okay, the antiderivative of e to the x is itself, we can get v pretty quickly. Don't worry right now about the plus c. At the very, very end of this integral, I'm going to put a plus c on there because it's an indefinite integral. It's an antiderivative. So I'm just going to kind of cut that corner right now. Hopefully you can be patient with me. All right. The other thing I'm going to need just later on is du. So just so you know, du dx is equal to 1, which means that du would be 1 dx. So I think with all of these functions, I'm actually going to apply the formula right now. So let's see if you can stay along with me, or you can pause it, the video, and try it on your own. But it says that we're going to have, u times v, so it would be x times e to the x, right? This is u times v, minus the integral of voodoo, vdu, kind of rolls off the tongue, v du, which would be 1 dx. So we're almost done, but the final answer is right in front of us. The answer is going to be x e to the x, but then I still have to integrate this leftover integral. And in this case, it's an easy one. And then I'm going to have my my c at the end, my single constant of integration. And that's going to be my answer. If you wanted to check it real quick, we won't do this every time, but if you took the derivative of your answer, you should be able to work backwards and get the question. So the derivative would be product rule here, product rule, u prime v plus uv prime. The derivative of e to the x is e to the x. The derivative of c is 0. And then notice you've got these canceling. And we've gone back to the original. Dun, da, da, da. So that's integration by parts. Obviously, there's some additional things to talk about, but we'll get to that. So let's try another one. Let's try x squared sine 2x. And I'm going to move quickly because I want to cram in as much as I can in this video, but you can pause it and try some of these things on your own. So I'm going to set u equal to this, and I'm going to set dv equal to sine 2x. A question that comes up a lot is, do I always use, does it matter what I use for u and dv? And it does sometimes. Sometimes you only have one choice. My advice to you is if you have a polynomial, x squared, x cubed, anything like that, use that as your u because the derivatives become less powers, less degrees. The degree goes down. And if you start taking antiderivatives, then the problem kind of gets worse. So, but we'll see what other examples we can get into in this short amount of time. So I'm going to set up du real quick, and I'm going to set up v real quick. Be careful here. The antiderivative is going to be negative cosine, and then I have to balance it out with a 1/2. And now I'm going to jump right into the integration by parts. So the first part of it, if you forgot, is u times v. So I'm going to have a negative 1/2 x squared cosine 2x minus the integral of v du. So I'm going to write the whole thing out, which is v du. But as you do a few of these in practice, you want to start kind of simplifying as you go. And I like to pull constants out, meaning we've got this constant, we've got this constant, and in this instance, we've got a minus. And so it really becomes a plus. And then the 2 and the 1, 2, the 2 and the 1, 2, the 2 and the 1/2 cancel out. And what I'm left with is this. I really hope I'm not making any mistakes. There's a lot of steps on these, and usually in class it's nice to have 30 students kind of keeping me accountable, but I'm not in class right now, so I'm double checking with my eyes. All right, so what you might notice here, this is the pain or the potential issue, is that this integral is another integration by parts. So this is where this technique can become a little bit frustrating, meaning that I now have to do a new u and a new dv. And I'm also running low on space. So du is just 1. But if dv was cosine 2x, we're now going to have kind of a 1/2, sine 2x. Man, space is an issue right now. So within this integral, I'm going to have another integration by parts, another u times v, which is going to be 1/2 x sine 2x. And then my new v and my new du. So I'm going to have a 1/2 sine 2x. All right, I'm going to rewrite this one time and then finish the problem just because the space is so terrible. I'm sorry, guys. Get your reading glasses on. We got x squared cosine 2x plus 1/2 x sine 2x. That's this guy. And then minus 1/2 integral of sine 2x dx. So again, second round of integration by parts. When I finish this integral right here and then put my plus c at the end, I should be good to go. So I believe the final answer after all this is essentially these first two terms. And then when I integrate this, I'll show the step, but the integral of sine is, negative cosine 2x and then times an extra 1/2. So I think what's going to happen is it's going to become a plus 1/4 cosine 2x, and then there's a plus c. And then I've still got these other guys along for the ride. I really hope I didn't mess up. It'd be a bummer. All right, I think that's the answer. So I don't want to be cut too short on time. I should be able to figure out how much time's elapsed, but I can't remember. Anyway, there is a shortcut that I don't have time to show you, and maybe I'll make another video. Well, depends on how many views this gets. But this can become kind of nasty because just think about this. If your teacher was cruel enough to give you, this integral, the idea here is that you might have to do integration by parts a bunch of times, and that can get very time-consuming and frustrating, and there's a lot of room for error. Again, I hope I didn't make an error. And so there is another technique that we'll save for another video called rapid integration by parts, where you kind of capitalize on some of these patterns. So anyway, I hope this helped a little bit. Thank you for watching, and I will see you soon.